I have been involved in the indoor environmental quality for over 20 years, addressing or helping clients achieve good indoor quality. Some of the buildings that we have done assessments for include from residential. Years ago, we started in the residential market. Now we do all the commercial, large buildings, schools, federal complexes, and definitely have, oh, that's not started. And so, yeah, we have experience with a number of different buildings, and we have addressed a number of different problems that buildings have because they, as a result of deferred maintenance over the course of the years, many of the buildings have gone with indoor air quality problems. And now we're beginning to see that there's definitely a trend with all these environmental consultants or the sustainable wave, the green buildings, and the high-performance buildings, Aguirre specifically. They promote a lot of these repairs that buildings need to provide a more high-quality environment for the occupants. So with that being said, let me just jump into this. We're going to review a few buzzwords, or not buzzwords, but a few terms that are very necessary to understand the environmental quality. And many of them you probably have them, but I'd like to go back to basics so that we can understand better what the presentation is about. So sustainability is a term associated with the cost-effective of the environment, responsible practices for facilities that address the comfort and well-being and productivity of the occupants. And really, the occupants are the ones that are driving all this indoor environmental quality, because without occupants, we would not have the need for buildings. And so everything is aimed to providing a healthier, safer environment for the occupants. A sustainable building maximizes daylight, has appropriate ventilation and comfort. It optimizes the acoustic, the performance of different other attributes. And they use materials that are more friendly. They have low VOCs, or volatile organic compounds, formaldehyde, and they strive to provide all these materials that are more or less harmful for the occupants. So the highest return on the construction on the dollar is human productivity. And once again, that is the crux of all this sustainability is the occupants. If we can provide an environment in where the occupants can perform their activities, they can do their work, they can study, or they can teach, or they can do their office work, then their productivity is going to be much higher. We do know that there are aspects on the air quality that is going to affect their performance, and therefore we need to increase the sustainability of the indoor air or the environment itself. So Americans spend an average of, according to the EPA, Americans spend an average of 90% of their time indoors, and for that reason, the quality of the indoor environment has a significant influence on the well-being and the productivity and the quality of life. A lot of these things, you probably heard them and you read them once in a while, but I think they make a lot of sense. And because of that, the public is becoming increasingly more aware about the environmental hazards and their health. So it's not like it used to be before. A lot of people didn't know what was going on in their environment, and they didn't know that that environment could be affecting their lives. As we increasingly spend more time indoors, the importance of indoor environmental quality is becoming a more valuable commodity. Even cartoonists are catching on with that idea. Here we see how this child goes outside, and he thinks that he's playing outside, but he's actually spending a lot more time indoors. It's not only children, but adults too. With the advent of the Wii, we can see how a lot of people now, they're playing more indoors than they're outside. So definitely, we are spending a lot more time indoors than outside than generations back. So indoor environmental quality is a term referring to the suitability of the environment as it relates to the comfort, safety, and health of the occupants. So once again, we're going to hear quite often environmental safety and health for the occupants and their comfort, of course. Indoor environmental quality relates back to biblical times. In the book of Leviticus, we read chapter 13 and 14, we read that the priest gives instructions to the people on how to deal with mold-contaminated articles and homes. So it is not a new thing. It's been in existence forever. Today, the World Health Organization has estimated about 1/3 of all buildings are afflicted with indoor air quality problems. That's a lot of buildings. That's a lot of problems that we have to resolve. And that's because the stock of buildings today is huge compared to the amount of buildings that are being erected right now. So we're going to focus not only into new buildings, but we're going to try to address some of the existing buildings as well. Good indoor environmental quality is a key goal for high-performance buildings. That is according to the High Performance magazine. They do have a lot of good articles in their publications, and they have even stated that in their publications that the Energy Independence and Security Act of 2007 that was signed by President Bush suggests that high-performance buildings are buildings that integrate and optimizes on a life cycle basis all the attributes that makes them green or sustainable. And that goes to say, for example, energy, air quality, the environment, things that will have sustainability and green. So the challenge now is to define high performance because there is actually no goals or metrics that exist to measure or demonstrate that a building is high performance. It simply doesn't exist. However, most authors will agree that a high performance building involves understanding what the existing conditions are, analyzing on a cost-effective way to see if the repairs will be sustainable, in other words, that are going to be feasible and beneficial for the occupants without having to spend money that is not necessarily going to be productive for the building owners. Having so many metrics in the indoor environmental quality, we can see buildings that, indoor environmental quality is a small metrics that we use for sustainability. And we're going to concentrate in the indoor environmental quality at this time. We're not going to touch energy conservation and all that kind of things because the topic today is indoor environmental quality. There are so many different factors that can affect the quality of the indoor air, from housekeeping or, from the conception of the building, how it was designed, the building materials that were chosen, how we operate and maintain the buildings, how many people are occupying the building, whether they're close, proximity to other buildings, factories, and things like that. Everything is going to affect the quality of the indoor air. And we try to give you an insight that everything that we do in our buildings is going to affect the quality of the indoor air. Having so many different factors, we also have a number of different authorities in the indoor environmental quality. The Environmental Protection Agency is one of them, and I'm going to list a few of them without going much into detail. But the World Health Organization, the U.S. Department of Health and Human Services, ASHRAE, the American Industrial Hygiene Association, the American Conference Governmental of Industrial Hygienists, the Departments of Business and Professional Regulation here in Florida. Of course, they want to regulate what we do. The Consumer Product Safety Commission, and others. So there is a lot of different agencies that have something to do with indoor air quality. they want to either regulate it or they want to tell you how to achieve good indoor environmental quality. And everything is because most of this, the thing is that a lot of the occupants are becoming either sick or they have concerns with the quality of the indoor air now. And because there's a health concern, we need to focus on achieving good indoor environmental quality. So we can go weeks without water, days without food, but only a few minutes without an adequate supply of clean air. Okay? So the most common ways that a pollutant can enter your system is through your respiratory system and then through your skin. The health effects depends principally in the toxicity of the contaminants that you're going to have, the duration of exposure, but most importantly on the susceptibility of the individuals. If there was, again, no occupants in our buildings, it doesn't matter what you would have in the buildings because it's just not affecting anybody, any person in specific. So we do know that we have occupants and people that work in buildings will have either a short-term exposure or long-term exposure to those chemicals depending on how long they occupy the building. So symptoms related to the indoor air quality or indoor air pollutants are mostly idiopathic, meaning that we know a little bit about them, and many of them are going to give you a headache or watery eyes or sore throats and things like that, but we don't know what is exactly causing that, that specific symptom that you may be experiencing. The good thing is that indoor environmental professionals do not deal with the health of the individuals. We're here to deal with buildings. Okay? We need to make sure that we're providing a healthy building, and the health of the occupants is going to be addressed more by a medical, a doctor or a physician. A few terms that I'd like you to revisit today is the sick building syndrome, which is used to describe a combination of non-specific ailments that are temporarily associated with the quality of the indoor air. Non-specific meaning, again, watery eyes, headaches, sore throats, and things of that nature, because anything else can give you also a headache. It's not necessarily the environment, but it could be, I don't know, the amount of reading that you're doing or the lights that are taking place. The light is not proper for the type of work that you're doing. So there's a lot of things that will give you those watery eyes or those complaints that we typically get from indoor air quality complaints. Again, irritation of the eyes, the nose, and the throat, and the lack of concentration, dry skin, etc., are examples of non-specific ailments. Similar term is the building-related illnesses. Building-related illnesses do have a very specific, it's a term that refers to a well-defined illness that is a causative agent resulting from the exposure to a building's air. In other words, the other ones we didn't know what caused your symptoms. These building-related illnesses, there is definitely a causative agent. So we have Legionnaires Disease, for instance, Hypersensitivity Pneumonitis, and humidifier fever are common examples of building-related illnesses because Legionnaires Disease is acquired by breathing droplet nuclei, and then a doctor can actually prescribe, they can do diagnostics on your blood or whatever it may be, and identify that you do have that specific condition. Just touching a little bit more on the Legionnaires disease, it is characterized by fever, chills, cough, and it's an infectious disease and it's potentially fatal, caused by the inhalation of the bacteria Legionella. Bacteria Legionella pneumophilia. It is very commonly found in cooling towers for air conditioning systems. It's very commonly found in domestic water heaters. Okay? And why cooling towers and domestic water heaters? It's because these two mechanical components have temperatures that are similar to our temperatures, 98 degrees. And so when they grow very well, if they grow well in that environment, in the cooling towers and in the domestic water heaters, then they can infect the humans. So they do like these warm environments, and specifically they live where the water is stagnated. In other words, in many water heaters and many cooling towers, we see sedimentation where the bacteria is growing much better than it would be in the upper layers of the cooling towers. Cooling towers have water that moves very rapidly, and that type of bacteria does not like the movement. So we just need to allow the bacteria to move into the upper layers. The temperature is the only one thing that is going to kill bacteria most effectively. You can hyperchlorinate as well, but it doesn't like temperatures greater than 105. It can survive up to 115, 125, but it will not proliferate beyond those levels. So hypersensitivity pneumonitis, that's another term that we use. It is marked by symptoms very similar to those of Legionnaires disease, but it is not a product of a bacterial infection. It is more than anything else the inhalation of organic dust. Organic dust such as mold, fibers, skin cells, opaque particles, and all kinds of things that we can see under the microscope. Other people may have problems that are related to multiple chemical sensitivity, which is a chronic medical condition of hypersensitivity. When people get exposed to chemicals in high concentrations, their bodies may react very abruptly against it. And then they become sensitized. Thereafter, they may be exposed to very low concentrations, and their bodies are going to react very abruptly, as if they were being exposed to high concentrations again. So that is why their sensitivities are exaggerated, and they react at very low concentrations of chemicals. Asthma, just briefly touching on that, that's another medical condition marked by shortness of breath, wheezing, and chest tightness. Asthma is typically aggravated by environmental conditions and genetic factors. So one of the things we can control is exclusively the environmental conditions, but we cannot deal with the genetic factors at all. So we need to provide buildings that are more hygienically well maintained to prevent asthma, the aggravation of asthma. I want to move a little bit more into the heating, ventilation, and air conditioning and the indoor environmental quality. And I was doing a little research, and I found that Aguirre, they described the air conditioning system as the assembly of equipment for air treatment to simultaneously control the temperature and the relative humidity and the cleanliness and distribution to meet the requirements of a conditioned space. In other words, the most important thing that I'd like to highlight here is that they did take into consideration the cleanliness of the air conditioning system, because we do know that we cool it, dehumidifier, to deliver the air to distant locations. And the cleanliness is a very important thing, because they use filters to begin with, and they bring fresh air to dilute the contaminants. So it has to do with the cleanliness of the air. Indoor environmental quality is a perceived indoor experience in the building indoor environment that includes aspects of design, analysis, and operation. But most importantly, what I want to tell you with this is that they consider energy, health, and comfort as three different aspects of the environmental quality that go always together. If we don't have clean buildings, we don't have health. If we spend too much energy operating the air conditioning systems, we're going to spend a lot of money, but yet we cannot provide adequate or clean air quality. And comfort is the other. We need to manipulate the comfort in some cases to achieve certain levels of comfort for different types of people. But if you lower the thermostat, it's going to probably save energy, but it's not necessarily going to provide the comfort levels that are required in the building. And I know I'm going to far into basics. I know I'd like to go back to basics so we can understand these terms that I'm about to bring a little bit better. So temperature is an objective comparative measure of hot or cold, and is measured typically with a thermometer. Relative humidity is not humidity, it's the amount of moisture that air contains relative to the saturation point. Right? So we know that 60% is about 40% away from being into the saturation at the point that air cannot hold any more moisture. So that is relative humidity. Aguirre has provided a nice comfort zone in which most people will find it comfortable. And we agree with that. They consider not only the type of space, they consider the type of activities that you have, the air movement, and a few other things. But the most important factors in this table is temperature and relative humidity. So if you're typically within that shaded area, you're likely to find your comfort zone. We do agree mostly with this table or with this graph. However, for indoor air quality considerations, we like to maintain the relative humidity between 30 and 60%. It's not for comfort, it is just to maintain better air quality levels. The higher the relative humidity, the more problems that we're going to encounter. We study buildings, and with this graph is just to show you that while the temperature was maintained pretty much within at 75 degrees, the relative humidity went up and down. We do have complaints about comfort. Comfort is one of the main issues that we encounter with indoor air quality complaints. And we need to analyze what's causing the relative humidity to be elevated or come down. Through building diagnostics, we can find a number of possible situations that could be happening from this chart. And with this specific graph, we found out that when they cycle off the air conditioning system, the exhaust system keeps running overnight, and then that raises the relative humidity. Okay? It brings the building pressure negative, and it increases the relative humidity. Other examples of analyzing temperature and relative humidity is illustrated with this graph, and I thought that was pretty interesting because I quite often get asked, is it better for me to keep the fan running all the time or to keep it coming on and off with the thermostat? And the answer to them, according to this graph, and I can see the results here, is that it's much better to keep the fan coming on in the automatic position than keeping it on, because the moisture that the coils hold a lot of moisture, and if you keep circulating air through that coil, the moisture is going to evaporate back into the environment. So the graph shows how it cycled on and off the compressor, but the fan kept going on. So these are things that we can, through diagnostics, assess buildings and give resolutions on simple things. Put your thermostat in the automatic position. This is a graph that I really like. It really illustrates the optimum zone for relative humidity. And we can see how bacteria and viruses and the prevalence of allergic rhinitis and asthma, and they are more prevalent when the relative humidity is either too high or too low. So for these microbes, it's not necessarily having low relative humidity. Bacteria, we have a lot of bacterial infections in dry months. Okay? Fungi is going to like it more wet. Yes, sir?
I'm not familiar with that at all.
With
bacterial growing in low humidity.
Research has demonstrated that, and we can ask our microbiologist when he comes and talks about that, and he may give you the reasons why. But the prevalence of bacterial infections are much greater, and I think it has to do with how your mucous membranes and your respiratory system is more prone to allowing the bacterial infections. Okay. We need to talk, if we're talking about HVAC, we need to talk about ventilation. Ventilation is used for introducing fresh air and exhausting stale air. Okay, it needs to be done in a controlled manner. Bringing outside air through an uncontrolled pathways is really not a good idea. So the intent of ventilation is for diluting contaminants that are present in the air. And that's the only reason that we bring fresh air into a building. ASHRAE 62.1, they said you can comply with ventilation rates using the IAQ procedure, or you can comply using the rate procedure, which is a prescriptive approach to the outdoor air rates. And it depends on the application and occupancy of the floor area of, that you're dealing with. For instance, if you have 10,000 square feet and you have 50 occupants, then you have to have a certain amount of fresh air brought into the building based on the number of occupants and on the size of the building. Okay? For people-related sources in office buildings, they recommend about 5 CFMs per person and 0.06 CFMs per square foot. For physiological contaminants, body odor, they recommend that the carbon dioxide be used as a surrogate measure to assess the adequacy of the ventilation system. We do not study carbon dioxide as a contaminant because in most buildings it is not. It needs to get, carbon dioxide needs to get to perhaps 13, 14, 15,000 parts per million before it becomes a contaminant. But carbon dioxide in indoor air quality assessments is used to assess or roughly understand the adequacy of the ventilation system. As people enter the building, they're going to produce carbon dioxide. So the more people enter the building, the levels of carbon dioxide are going to increase if no ventilation is provided. So with ventilation, we can control the amount of carbon dioxide, and with that, we control the amount of bioeffluents that we generate, body odor. And so they say that if we use carbon dioxide to measure the adequacy of the ventilation system, the carbon dioxide levels inside of our building should not rise 700 parts per million over the outside air levels. Typically, the outside air contains about 300, 400, some cases 450 parts per million. So with the 700, we see that about 1,000 to 1,200 parts per million are normal in a building that is properly ventilated. And here we go into talking about pollutants and the different types of things that can affect the air quality for buildings. So we have bacterial colonies, which are mostly in buildings, bacteria that are human source bacteria. We not necessarily have a whole lot of environmental bacteria like soils and things like that, but most of the bacteria that we identify in indoor environments have to do with the occupants. For the most part, they are non-pathogenic, but in some instances, we can see how people have medical conditions, infections of the skin and things like that that can be transmitted from person to person or by contact. But bacteria is well known to produce a lot of odors. In other words, if you probably have seen, I have experienced many times where I go to resolve an odor problem, I go and I see the environment, I see carpets, and I see that there are occupants. Occupants shed a great deal of skin cells. Skin cells are loaded with bacteria, human source bacteria. You add a little bit of moisture and it becomes an odor problem. Okay, so it's important to maintain the relative humidity between 30 and 60%, and we don't want to keep the carpets wet at all. I mean, you need to shampoo them, you have to do whatever you have to do to maintain them clean, but that moisture needs to be recovered as fast as possible. Normal concentrations in the indoor air of airborne bacteria range approximately 175 to 350 colony-forming units. That's just about the normal level of bacteria. We cannot keep the environment sterile. We're always going to have some bacteria and fungi in the air, but we try to keep those between 175 and 350. When we see the bacterial levels growing, maybe we need to look at situations like the ventilation system and the housekeeping protocols, okay, to mitigate the problem with bacteria. There are some bacterial species that are of concern. Legionnaires species we already talked about can cause Legionnaires disease. Pseudomonas aeruginosa can cause meningitis. There's a very specific type of medical condition. Mycobacterium tuberculosis, of course, causes tuberculosis. Bacillus anthracis is what causes the anthrax and is used for bioterrorism, and it's a well-known type of bacteria. Bacillus cereus causes a lot of skin infections. And then we're going to see another similar bacteria that is called Staphylococcus aureus, and is responsible for the MRSA. MRSA stands for the methicillin-resistant Staphylococcus aureus. And that is transmitted from person to person, just by contact or by touching surfaces that have been already infected. It is very difficult to control because it's resistant to all the medications that you can take. And although it is quite common, a lot of people that have, especially those with susceptible systems, are not going to be able to fight it very well. It causes a lot of deaths. We have fungal colonies. Fungi is ubiquitous in every habitat. It colonizes moist environments, like we saw on our graph for the optimum relative humidity. It likes wet environments rich in carbon. They are saprophytic, meaning they eat dead stuff. Many produce objectionable odors, or what we call microbial volatile organic compounds. They are multicellular organisms, contrary to bacteria. Usually they are just unicellular. They reproduce by spore germination or by fragmentation. In other words, you can have the spore, the seed, if you will. It can initiate growth, and it can proliferate. Similarly, when molds are broken into pieces, the pieces fall in the proper substrate, and they can initiate growth. Why is this important? It's extremely important because by nature, fungi are going to try to grow and reproduce specifically by the spore germination. But if we have a building that is infected, we have a mold problem in a wall, for instance, and I send someone to just vacuum it out without the proper equipment, they're going to vacuum it, or they may just dust it or clean it, and they're going to break the fungal elements into multiple pieces. And each of those have the capability of initiating growth. So it is thousands and thousands of times more the likelihood you're going to have a contaminated environment than if you were to do it properly with vacuum cleaners equipped with HEPA filtration. So it is important to know these things because molds can reproduce very rapidly, can take an environment very rapidly. Normal concentrations of fungi in the air, when we culture it, sometimes we take cultures, and we're going to see that, range between 350 and 700 colony-forming units. That's the normal concentrations in the air for buildings with adequate indoor air quality. We measure the amount of fungi that is, and bacteria that may be in the air, using an apparatus like the one that we see here. We have a pump on the bottom. We have a metering device. We have a hose that connects over to an impactor that we call. Inside of that impactor, we insert a Petri dish that has specific media for bacteria or fungal growth. Okay? So air is going to actually enter the impactor and is going to inoculate the Petri dish that is inside. Once we take the Petri dish out of that impactor, we turn it over to the laboratory. They incubate it. But first of all, let me just go back a little bit. We do know the amount of air that was drawn through that instrument. So the object of knowing how much air is going through that is so that we can quantify. If we don't know how much air went through that sample, we cannot quantify it. And quantifying is one of the most basic things that we need to do to understand that we're bringing the environment back into more of a controlled environment instead of having no ways of defining whether we did good or bad when we clean a building. So we need to quantify it, and if we know the amount of air that went through that, we can definitely give you the colony forming units in counts per cubic meter of air. Real life example, we have that with those 3 Petri dishes. I went to this building and they tell me we did have a water intrusion event. We see some mold growth that is taking place on that wall. And we went to other places and yes, they had a storm that came over and water intrusion took place. We have a lot of people that were concerned about the air quality and they claim that they are so allergic to mold that they cannot live in that environment. So it is a pristine building, but yes, they do a few locations. We go out there, we measure, we take air samples, and sure enough, we find a great deal of fungi, and you can see it on the left plate, in the upper left plate. But the bacteria that we found in great concentrations was not in the building. It was in the outside air, okay? So this is one of the reasons that is very handy to measure the quality of the indoor air, to demonstrate that the environment has a problem with bacteria or fungi or not. We need to see that people, well, actually, let me just go back to this. The first plate on the bottom is my blank control. Nothing is growing in there. And we can see the indoor and the outdoor air sample that was collected. So when I go and explain the results to the occupants, not to demonstrate that they're bad and they're just whiners, hypochondriacs or anything like that, but scientifically we're trying to tell them that the environment is safe. And if they're experiencing allergic reactions, it's not necessarily because of the fungal elements that they have in the building, because they are several orders of magnitude lower in the indoor air than those that we have outside. So with that, we put them at peace and we say, yes, we have other situations that may be causing your allergies, but it is not mold growth. It is not because you see that patch of mold up there. And we should not tolerate it, we should address it, but it is not the mold that is causing your allergies. It's gotta be something else. They say, well, I feel much better when I go outside. You cannot feel better with respect to mold when you go outside because it is so much heavier, the contaminants outside than they are in the indoor air. So there are aerosols that we measure, not only bacteria and fungi, but we also measure several types of aerosols. Aerosols meaning things such as fungal elements. Now this is a sample, things that we don't culture. We just do an analysis. We take a sample from the air and we do an analysis through a microscope. So pollen, for instance, that's a very well-known allergen. We just are coming out of the pollen season, and a lot of people were reacting because of the exposure to pollen. Skin cell fragments, that's a very common allergen that we find in the indoor air, unknown surfaces as well. Fibers are a ton of fibers in the air. As a matter of fact, many of them we see them on the desks, and they come from the carpets and from the clothes that people wear. Washer and dryers, they're not very effective at exhausting properly all the fibers that we have, and they are aerosolizing the environment just from the effect of drying our clothes. Fibers could also be derived from building materials. Fiberglass fibers are quite often detected in the air, and that's because the building materials are degrading themselves. They may be coming from the insulation materials we have, through either infiltration or from maintenance activities. We have seen many times how the maintenance people lift the ceiling tiles and fiberglass comes crashing down. And it's not the bulk of the fiberglass that I am concerned with, it's the ones that become aerosolized as we lift the ceiling tiles. We have insect parts, opaque particles, and black particles. Opaque particles are mostly like non-organic material, concrete, drywall dust, things like that are going to look opaque under the microscope, okay? There are black particles that are more of an organic material. That may be like soot, for instance, from incomplete combustion, from diesel vehicles. I have seen in some situations the emergency vehicles parked in front of the entrance of the hospital, where the fresh air is right on the side of it, and all the diesel fumes enter the fresh air system. People complain about that, and you definitely can see that it gets darkened around the intakes. The concentrations are there that are typically in environments. It's not really important to discuss that right now. But these aerosols are collected. We understand what is in the air by using a cassette. That cassette works in the same principle as the other type of sample, by impaction. It draws air through the cassette. On the bottom we see a hose. On the bottom there's the same pump that we had before. We draw air through that cassette. It funnels it down to a very thin or small slit, and the particles that were suspended in the air now are impacted on a microscope slide that is coated with a gel material. It's a sticky material. So the particles are impacted on that gel. And when I turn those into the lab, they will open the cassette and they extract that microscope slide and they analyze it by morphology. And they can tell you which one of those aerosols that you have. You can also collect aerosols or assess the concentration of dust that is on surfaces by taking what we call the surface tape prep. The surface tape prep is going to be applied to the surface of interest, then you peel it off and put it onto a microscope slide, and it's, in the same way it's going to be analyzed in the laboratory. So it is nice to understand what's in the air and what's on surfaces, because with that you can make connections of what's going on in your environment. If you have too much fibers, then you can start looking at, well, what can be producing fibers in the environment that are so prevalent? You go to your vacuum cleaners, housekeeping, understand if the filters are working properly, and 7, 8 times out of 10, I will find that the bags of the vacuum cleaners are completely clogged, and they are just, picking up the bulk, but the finer particles are escaping the filters because they are so loaded. Even when they use high filtration filters, but the bags should not hold so much dirt that they begin to release these contaminants back into the air. Similar test that we did with the bacterial and fungal concentrations. We see this slide where we have the air in the building inside, okay? And this is a sample that we collected with the cassette. And this is what you see from the air outside. Okay, we see, okay, maybe a fiber, some skin cell fragments, perhaps some opaque black particles. But on this side, we see several orders of magnitude more particulate, more contaminants in the outside air than we see on the inside air. And this is a problem building that what I went to analyze. So when people tell me I feel sick every time I come into the building because of all the dust, the bacteria and the fungi, I need to analyze what is floating in the air and demonstrate, at least give them a peace of mind to say that it is okay, the building or the air in the environment. It must be something else. Now, when we talk about chemicals, that's a different thing. Chemicals are going to be a lot more prevalent inside than they are outside. And I know the EPA and some other agencies have made the comments that indoor environments are 100 times more contaminated or 1,000 times more contaminated than the outside air. And I think they're right, but they're wrong in saying they need to be more specific with respect of chemicals. And EPA is very big in assessing chemicals in the environment. They are not very often measuring aerosols, bacteria, and fungal levels. They mostly do their assessments with respect to chemicals. Other things that we measure is respirable sized dust. Respirable sized dust is very fine dust that is typically in the environment, in every environment. And why respirable sized dust? Is because it's so fine that it can enter the alveolar region of the human lungs and begin to cause infections and respiratory problems. Larger particles are not going to go all the way down into your lower respiratory system. They're going to be trapped on your throat, on your mucous membranes, where we have protection. We have cilia that keeps moving all this mucous membrane out, and it cleanses naturally the airways. But once it reaches the alveolar alveolar region of the human lungs is not very easy to get rid of these contaminants. So it's 0.3 to 5 microns, and it is measured using a handheld particle counter, similar to the ones they use in clean rooms. So we know that by taking so many samples, indoor, outdoor concentrations, we know what environments with good environmental quality, they should have approximately 25,000 counts per liter of air. And in the outside air, of course, it's going to range from very clean to very dirty conditions, but typically above 50,000 counts. It can reach the alveolar region of the human lungs. It exists in the environment in the highest concentrations. The smaller the particles, the more are going to be in the air. The Environmental Protection Agency monitors the levels of particle mass 10, or I think it's particle mass 10, because it can cause so many respiratory problems. In the indoor environment, we utilize the same idea, but by measuring concentrations and determine whether there is a situation that is releasing respiral-side particles into the air, like the housekeeping, or the building is beginning to degrade. Sometimes we see the relative humidity control in an environment is not very good. The buildings begin to deteriorate with the higher relative humidity levels. And therefore, maybe the materials, the carpets, the walls, the ceilings, and things like that begin to degrade, and we can see an increase in respiral-sized particles. Now that we can move now into allergens. You'll see that there is a ton of different contaminants that we need to be concerned in the indoor air quality. Cats. A lot of people are allergic to cats and cat allergens. Cockroaches, dust mites, rats. And for the most part, we are allergic to saliva, the dander, and they can cause respiratory problems such as the same thing, non-specific ailments. They can trigger asthma attacks, and for susceptible individuals, of course. We need to wash our hands when we deal or handle these allergens. We need to use high-efficiency particle arrestance filters to clean these allergens out of the air. We need to make sure housekeeping is routine and they do a good job. Keep the relative humidity, again, between 30 and 60%. When the relative humidity exceeds 60%, the prevalence of roaches and dust mites are going to be a lot higher. Okay, so maintaining, again, the relative humidity between 30 and 60 is going to be one of the most important things that we can do in a building, not necessarily for comfort of the occupant, but just to reduce the prevalence of these allergens. In your air conditioning system, we recommend that you use MERV 8 air filters, at least, nothing less. If you want to understand the contaminants that are present in a building, it's done by collecting with a vacuum. There's a sock up here. You collect it and send it to the lab. They will tell you the type of allergens that were present in that specific sample. They can quantify it, and you can compare it with certain guidelines that are available for you to analyze to whether you have high or low concentrations. Okay. Now we pass allergens, we go into the chemicals. Again, volatile organic compounds are present in a lot of buildings. Specifically, culprits are the new buildings. And we have volatile organic compounds because the materials that we use to build these buildings have a lot of solvents and formaldehyde, so that we can make wood products. The flooring that we have, the ceiling tiles that we have, pretty much everything that we buy out there is going to have some level of chemicals in it. And if it is packed, if it is contained, it doesn't have a chance to volatilize, and it needs time to dry out, per se. All these compounds that are trapped within the wood products, they need to volatilize and go to the outside so that it becomes less noticeable. There's a number, not only construction, but there's also even personal products, personal care products, deodorants, cooking, Paints, roofing materials. There's a lot of roofing materials that will have volatile organic compounds, and if we don't take care of maintaining the building under positive pressure, they are likely to infiltrate into the building. We have seen several situations with that, one just recently that was quite interesting. We definitely modified the ventilation system. We closed off the exhaust, and we rerouted the fresher air intakes away from the roofing that was being replaced, and we turned the building into a positive pressure temporarily. So the vapors generated by the roofing materials, they would not infiltrate through the small crevices and holes that are present in the roofing deck. That made a big difference, and we were able to complete the project successfully. Again, symptoms to exposure to volatile organic compounds include eye irritation, nose and throat discomfort, headaches, lethargic, nosebleeds, and dizziness. So, you know, there are also, many of these are, again, non-specific symptoms, but it's very classical to see people who have used these volatile organic compounds, they become really lethargic, and you can see the symptoms in people who are addicted to volatile organic compounds. So they're expressed in parts per million. They are typically several orders of magnitude lower than those found in occupational settings. In other words, for indoor air quality, we don't necessarily have to go and analyze the occupational exposure because that's not the goal. For air quality, the concentrations of volatile organic compounds is very, very low. Many of these compounds have low odor threshold levels, meaning that with a little bit of these VOCs, you're going to detect a lot of it. And it is not because they're present in high concentrations, it's just because we as humans, we can detect these odors very, very rapidly at very low concentrations. They're expressed as part per million. And there's only this one author who indicates that 0.64 parts per million of total volatile organic compounds is the guideline that they provide for you to take action in a building. Above these levels is not a normal condition. You have room for improvement. Ventilation is, for instance, the #1 tool that you can use to minimize the airborne volatile organic compounds. Samples are collected either with a dosimeter, like the one we see up on the left corner, or by a pump, passive or active sampling. They have substances on the inside that are sorbent, and they analyze it in the microscope. In the laboratory using gas chromatography and mass spectrometry. More chemicals. We have now the ozone. And again, ozone is something that exists mostly on the outside air. Sometimes it's generated within the indoor air. Ozone is sometimes used to sanitize environments because it's a very strong oxidizer, and it kills bacteria and fungi, and it combines with other chemicals and takes away a lot of odors. The problem with ozonators is that the ozone is also an irritant to the human lungs and to the throat and the respiratory system. So we should not be using on a constant basis the introduction of ozone into a building. It's okay to use it as a disinfectant, and once you are finished with your dose in the building, you need to ventilate that area very thoroughly and then allow the occupants after the levels become normal again. Okay. It increases the susceptibility to respiratory infections. And one of the reasons, perhaps, just going back to the comments that we made about bacterial infections, is that when the relative humidity is very low, then the prevalence of ozone is going to be greater. Okay, ozone is, like we said earlier, is a naturally occurring chemical. So when you irritate your airways, then the susceptibility is going to be greater. The susceptibility to infections is going to be greater. More chemicals. We have radon. We have so many things that can affect the quality of the indoor air. And just going real quick, radon is the second leading cause of cancer in the lungs, killing 21,000 people in the United States each year. That is more than drunk driving, I think, they have there, falls in the home, and drownings. So it is a great cause of death, this radon. And it exists in different locations of the country at different concentrations. One of the things you can do is very simple. Buy a radon test. It's nothing but a sorbent media. You open it, expose it for about 72 hours, and they recommend an action level of 4 picocures. 4 picocures per liter of air. It should be considered in real estate transactions if you're going to buy property, not only in homes, but also commercial buildings, because the remedial work is going to be more expensive if you have it. All these allergens and everything else, again, is maybe aggravated by the environmental conditions, the shell of the building envelope, and the air conditioning systems. Because we change the nature of the ventilation system, we're trying to change the amount of moisture that is in the air. We're trying to remove it, but in some cases, we have to deliver it using fans. The fans are going to change the pressure within the building so that it can be supplied. If you cannot change the pressure within the building, then you cannot supply air. You need to have that pressure differential. And when you're changing the pressure within the building, then if the building is not sealed tight, it's going to allow too much infiltration. That infiltration is going to bring raw materials from the outside air, like the ones we saw in the microscope on the slides before. So we need to make sure the building pressure is maintained in the building, and that our exhaust, our ventilation system, exhaust and the fresh air are in balance, and that will prevent the building from becoming negative or positive. Neither one is a good thing. To have too much positive pressure is not good. Too much negative pressure is not good either. We'd like to see that balanced. When we build homes, we need to make them nice and tight. But the problem with not only homes, but also commercial buildings is that they are tighter for energy conservation purposes, but many of the new buildings lack adequate ventilation. So we need to understand that the ventilation needs to be looked at also to dilute the chemicals from the construction materials. And perhaps in the future, once all these chemicals are volatilized, then you can reduce the amount of fresh air you bring into the building. We have resolved a number of problems by adding ventilation to new homes or new buildings. And that's basically the only thing you can do for them. And then wait. Several months later, you can modify it to because it's not necessary to bring excessive ventilation either, because it's not cost effective. So we see our roofing, our insulation, your vapor barriers, things like the windows, the suspended ceilings, using return plenums or the space between the ceilings and the roofs as return plenums. Sometimes it's not a great idea. The building needs to be completely sealed. Otherwise, it's going to cause infiltration. You turn the plenum under negative pressure, and it's going to pull contaminants from every small crevice in the building. And we have seen some situations that the building was not necessarily built very tight, especially above the ceiling tiles, and it allows for a great deal of infiltration. Not only brings all the pollutants, relative humidity, the humidity is brought into the building before it passes through the cooling coils, is unconventional introduction of air. Stack effects are things that we need to look at. Practices like housekeeping, are important on maintaining your buildings. And we need to make sure that we use techniques and protocols that are not going to aggravate the quality of the indoor air. If you ask me what crew do I prefer, I think I will prefer that lady that is up here to come and clean my home or my office. Not because she is a nice lady, because these guys have brooms and things that are going to use to clean the house, and they're going to aerosolize a number of things. We recommend wet wiping and cleaning protocols of that nature instead of using dusters. I have seen a lot of schools that use dusters still, and they take the dust off the surface, they shake it over here, they go to the next location, everything is redistributed. So again, we need to see at all the tools that they use. Going into maintenance, again, cooling coils, air conditioning systems are a very important area that we need to give attention. If we clean cooling coils, we need to use, hopefully nobody is using any more pressure washers, because pressure washers are forcing this dust and things further deep into the coils. When we use steam cleaning, is a much efficient way of cleaning coils. It's going to sanitize, kill the bacteria and fungi, and it's going to remove the vast majority of the contaminants that you have inside of the pack. It's very important not only for health and safety, for mitigating the odors that you may have in a building, because sometimes you know that things are growing in your air conditioning system because they smell. Every time the air conditioning turns on, you can notice it. It also restores the cooling capacity, reduces absenteeism and operating costs, and so on and so forth. So we had an experiment that we had to make. One of the local universities here donated a cooling coil like the one we see up here. I keep pointing to that screen because I can see it towards you, but they donated a coil, which we divided in two sections. They removed that coil. It looks like an old coil because they were not able to clean it any further. They cleaned it several times, and they decided that it was better for them to replace the coil than trying to put more money into that dirty coil. They donated it. We split it in half, and we cleaned it with the steam process. And the other one, we left it the way it was. They had tried to clean it, but unsuccessfully were able to do that. So we put it inside a cavity with a fan on the other side, and we were able to measure, in this case, 371 cubic feet per minute flowing through that coil. After it was clean, on the opposite side, we were able to see that there was an increase on the CFMs of 631. That's a major increase, and just to prove that steam cleaning is a much more efficient way of cleaning coils. Okay, there was a study that was done by the Florida State University. They steam cleaned all the coils in campus, and they were able to realize a tremendous amount of savings. About 14 cents per square foot of building space, they calculated that. Real estate people like to convert everything you save and everything else per square foot. They realized that the energy savings was about 22 cents per square foot, and it was a 157% return on the investment with a payback of about 8 months. So if someone wants to clean the coils, there's a very good reason why use steam cleaning. This really concludes my presentation. I want to thank you very much for your patience. Hopefully this would be helpful for you. I'm open to answer any questions or questions that you may have. Sir. You have it. It's in that pen. Yeah. Yeah.
Give it about a day.
Oh, they already have his presentation
Oh, the
right on the pen.
presentation's already on there.
Right on the pen.
Yeah. The presentations are there. You have it there. Yeah. Yep.
Everybody's presentation is on the thumb drive on the pen.
Okay. Yes, sir.
Not that I have it in my house, but is there a way, I think I have a way to detect bed bugs besides, physical biting?
With all honesty, I have not done any assessments for bed bugs. We know that by increasing the temperature, you can control bed bugs. They hide very well in wall cavities and things like that, and they come out at night. So the fact that they use pesticides and things like that is not very effective because they are hiding in locations where you cannot. I would have to do a little research for you. I don't have the answer. Maybe Dr. Sahay, that is coming later, he might be able to tell you if there is a way of measuring that. Yeah. Yes, ma'am.
I was just going to say that there are some medical professionals that may have more stringent requirements about the relative humidity? Like I have allergies, and my allergist
Sure.
wants me to make sure that my house is 50% of that.
Sure, sure. There are more strict levels of relative humidity. You're absolutely right. As a matter of fact, most engineers design for 50% relative humidity. So if you're, and one thing is the design and is a little bit different, the actual performance, okay? One is they need to give you a design of 50% based on certain times of the year, the hottest day of the year in Florida for the different location. So they design 50% relative humidity with the expectation that it would maintain it between 40 and 60% or 30 and 60%. Okay, if you have more than 60%, then you really have a design problem. Okay, yep. All right. Well, thank you very much. Appreciate it. Thank you. Thank you.
We'll take a few minutes till our next speaker comes in. So Rick is our next speaker from Tremco. So people want to get up, get a drink, stretch. That way people can relax a little bit.